Okay, so in this video we're going to be finishing the review. As I mentioned at the end of the class last time, we'll be doing 45 through 59. And hopefully you have your paper and you can follow along, and if not, well, that's alright. This still should be understandable even without the paper. So, here we go. Let's see here. 45A. Alright, so we're going to perform the indicated operations, and then after that we're going to make sure that it's in mixed numbers and in lowest terms. So we have 4 and 10 over 11 plus 2 and 2 11ths. Now what we can do is we can add the whole numbers, or the integers, right? These are integers, these are rational numbers or fractions. So 4 plus 2 is 6. Now we can take this, and it's 10 plus 2. We can do that because the denominators are the same. So it's going to be 12 over 11. Now here's the problem here. We have a whole number and we have an improper fraction. So we need to change this to a proper fraction. Sorry, we need to change it to a mixed number. And we need to ask ourselves, how many times does 11 go into 12? Well, in this case, we could use long division, but let's just use common sense. 11 goes into 12 one time, so there's one of them. And then if I subtracted the 11 from the 12, there'd be 1 left over, so it would look like this. So I would say the answer is this right here. Alright, so this canceled out and became this right here. Then we added that, added the 6 to this, or we added this to the 6, and we got 7. And, oh, not 11 12ths. Oh my goodness. You see? I meant to say 7 and 1 12th. Terribly sorry about that. So that's the answer right there. This is not the answer. It's 7 and 1 12th. Alright? Let's go on to the next one. Let's delete all that. And let's go to 45B. Alright, 45B is 5 and 1/3 minus a negative 3 and 2/3. Okay? Now, when we have a negative and a negative, it becomes just a positive. So this is just going to be a plus. So we could rewrite this as this. Okay? Now, when we do that, again, it's 5 plus 3 is 8. And then we have 1 plus 2. We can do that because they share a common denominator. All right? They have a common denominator, which is 3, and so that's 3/3. Well, that's really just 8 plus 1, so the answer is 9. Okay? All right, next one. Next one's 45C. 45C. All right, so 45C, we have 1 and 1/6 plus 6 and 1/4. All right. Now, we're going to add the 1 to the 6, so that's 7. Then we have a 1, let's work on the fractions now. We have 1/6 here plus 1/4. All right, the common denominator here would be 12. So 3 times 4 is 12, 2 times 6 is 12, so we times top and bottom by 2. So we have 2 twelfths here. And then we have plus 3 twelfths here. And that gives us a 5 twelfths. 5 twelfths cannot be reduced, so it's just 7 and 5 twelfths. If we could reduce the 5, it would say it was like 6 twelfths. That would be 7 1/2. But since we can't reduce it, it just simply becomes 7 and 5 twelfths. All right, next one. Let's erase that. And we are on 45. We just did C, so now 45D. Here we go. 45D. Here we go. 45D. All right, we have 5 and 2/5, and we're going to be subtracting 3 and 3/4 from it. Okay. Now, we can take this 5 and we can subtract the 3 from it, so we have 2. All right? Then after that, what we have is we have this 2/5 and this 3/4. Well, we can't subtract those from each other. We can't subtract the 3/4 from the 2/5 until we get a common denominator, I mean. And what is the common denominator? Well, the common denominator in this case is 20. So we're going to times the top and bottom of this by 4 and the top and bottom of this by 5. So this turns into 8 20ths minus 15 20ths. So we're going to have a problem here because this is a positive 5 and we subtracted 3 from it. We have a positive 2 now. Well, when we subtract this 15 from the 8, we're going to get 7 20ths. So that's a negative 7 20ths right there. See that? It's a negative. This is bigger than the 8, so it's a negative 7. So we have a negative 7 20ths over here. We can't combine them into a mixed number until they share the same sign. This is a positive, that's a negative. So really, we have 2 minus 7 20ths. We could represent 2 as 1 plus 1, or we could represent it as 1 plus 20 over 20. Now the reason we can do that is because 1 can be represented as 20 over 20. Why? Because 20 over 20 is 1. So this is accurate. Then we minus the 7 20ths from that 20 over 20, and we get 1 and 13 20ths. All right, that's that. Now I was looking at 45a, and I think at the end I said it was something that was incorrect. We had a 4 and 10 over 11 right here, plus 2 and 2/11. And because I can't go back to what I erased, well, maybe I can. Let me see here. No, let's continue. Just in case I got it wrong the first time, I want to double check. It starts with a 6, and then we have a 12 over 11. All right. I think I said it was a mixed number with the denominator being a 12. That was incorrect. This is 11 goes into 12 one time, and then we have 1 over 11. I think I said it was 1 over 12. I just want to clarify. That turns into 7 and 1/11. 1 over 11. I think I said it was 7 and 1 over 12. I think I said it was 7 and 1 over 12. That was wrong. It's 1 over 11. Anyway, just want to make that correction. So that was, by the way, again, 45a. All right, now let's go to 45e. 45e. And I think I want a brighter color. I like this color, but I want it a little bit brighter. No, maybe not brighter, maybe a little darker. I guess. Come on now. Well, whatever. I can't. Here, let's just use yellow. How about that? That's a little bit better, I think. Or maybe what we should do is use a different thing here. Yeah, that's better. I like that. That's better. Oh, that's a little too much, though, isn't it? All right, let's just use this. 45e. Okay, 45e. That's a negative 3 and 2/3. All right, times a negative 1 and 3/7. All right, to do this, we need to change it into improper fractions. To do multiplication correctly, we should change to improper fractions. So let's do that. It's 3 times 3 is 9, plus 2 is 11. So it's a negative 11/3, okay? And we're going to times that by what this improper fraction is. So that's 7 times 1 is 7, plus 3 is 10. So negative 10/7, like so. All right. Now when we multiply this, we want to see if we can cancel anything out. In this case, we can't. We have 11, and we have a 10, and we can't factor anything out. So it's just going to be positive 110 All right, we can cancel those out, the negatives. Positive 110 over 21. All right, now we want to change this to a mixed number. And to do that, we are unfortunately going to have to do some long division, I do believe. All right, so 20 goes into 110 how many times? Well, if I round this down to 20 instead of 21, then it could go into it at least 5 times, and I think that's what we want to do. So let's do 21 times 5. That's 5, and this is 10, so 105. All right, and then we have a remainder of 5. Well, 21 doesn't go into 5, and we could bring down a 0 and put a point up here, but we're not going to do that. We're just going to have a remainder of 5, so I would say that the final answer is 5, and 5 over 21. That, I would say, is the final answer. All right, let's delete that, and let's go to the next one. That's 45F. All right, 45F is negative 8, all right, and 3/10 divided by 2 1/5. Okay? We want to change this to improper fractions. So 10 times 8 is 80, plus 3 is 83. So negative 83 over 10 divided by, this times this is 10 plus 11 is, plus 1 is 11. So we have divided by 11/5. Now we need to times by the reciprocal. So it's really negative 83 over 10 times 5 over 11. Okay? Now we can factor some things out. This 10 can be represented as 2 times 5. Therefore we can take this 5 and this 5 out. And then what we have left on bottom is a 2 here and 11 here and then 83 on top. So I would say it's negative 83 over 22. Now we need to use long division to change it to a mixed number. And we'll forget about the negative for right now. How many times does this go into this? Well, it would be 4, almost 4 times, but not quite, right? 4 times 20 would be 80, and then times 2 would be 8. So if it was 4 times, it might work if this was bigger, like like 89, but it's not. It's smaller, so only 3 times. And that is 66, like so. Now, we need to ask ourselves what this is. So we minus it, we still from here, add here, this turns into 7, and this turns into 1, so 17. So I would say that the answer, the final answer, is a negative, because we have a 3 here, so and we have a negative, we remember it's negative, we have a negative 3 and 17 over 22. I would say that is the final final answer. All right, let's go to the next one, 46. 46, and let's see, switch the page, we have 46A. 46A, and it's a negative 21.05 plus 2.5 plus a negative 13.91. All right. Well, the first thing I'm going to do is I'm going to probably, oh, hold on, this is a negative. Negative. I'm going to put these ones together right here. Now, this is a negative and this is a positive. The absolute value of this is bigger than this, so in the end I should have a negative left over, right? Now I like to do it kind of like this in my brain, and this kind of makes it easy. I put the negative on the outside, and I put a 21.05 on the inside. And really I should have a negative left over, but it should be a smaller negative. It should be a smaller negative because I'm on the number line right here. I'm at 21. I'm not going to put the decimal, it's just 21. And I'm going to be moving, this is negative 21, I'm going to be moving to the right of that, going in the positive direction, 2.5. So in the end, I should have bigger number, and it would be a smaller negative. So, you know, if it was if I just had 2 there, it would be you know, negative 19. So I want to go, you know, I want to think of this instead as a subtraction problem, because I'm, you know, I'm having a smaller number, smaller negative, and this is a bigger negative. So when we think of it as a subtraction problem at the moment, and just remember that it's negative, I should have a negative number at the end. So I put that negative on the outside. So anyway, let's put a 0.5 and then a 0 there. Let's erase this stuff down below. I don't want it in my way anymore. All right, very good. All right, and then put that, oops, make it a little bigger. All right, so now we have a 5 here. We're going to steal 1 from here, make that a 0, put that as a 10, make this a 5 here, put this here, and then look at that, it's 18. So we have 18.55, and it's a negative. Remember, it's a negative. And then we're plussing after that, so we've taken care of this, right? And now this turned into this. And now we're taking this, and we're going to add this to this. Well, we're adding a negative, so it's just really minus a 13.91. Now, again, on the number line, right, we were at this 18 here. We'll round up to 19. We're at 19 here, and now we're going to be moving back this way. So we can think of this as an addition problem now. We can think of this as an addition problem, and it's going to end up in, you know, we're going to end up with a negative number because we have a negative and a negative. So let's just do 18.55, and let's plus this 13.91 to it. And let's remember again that we're dealing with a negative on the outside. All right, remember the negative on the outside. So this is 6, and this is 14, carry the 1. Now we have 8 plus 1 is 9, plus 3 is 12. And we'll carry the 1 again, and so it's 32. And it's a negative. So again, negative 32.46. Now, I sent you the answer sheet, all the answers to this. And if you look on the answer sheet, you'll see that it's correct. It is a negative 32.46. Now, you can also check your work with a calculator as well. All right, 46B. 46B. Use different color. It's always good to use different colors. Put some variation in it. So we have a negative 41.98. All right, we're going to be minusing a negative 13.5. All right, again, we have a negative here, and now we have a positive, because a negative and a negative make a positive. So what we're really doing is we're going to be moving on the number line. We're over here at the negative 41. All right, we're moving to the right this way. That means that we're going to have a smaller negative number, and so we can think of this as a subtraction problem instead of an addition problem. And we can put the negative on the outside like so. So we have a 41.98, and we can subtract this 13.5. I'm going to add a 0 here from it. Okay, so that's an 8, and this turns into a 4. And then we can steal from here, make that a 3, make this an 11. So that turns into an 8 here, and then this turns into a 2. And then remember, it's a negative, so it's a negative 28.48. Like so. That's the final answer. All right. Now let's move on to the next one. Next one is negative 2.48 times, when you have a parentheses next to it, it's a multiplication, so it's 0.003. Okay? All right. Now, when we multiply that, we can just, since it's negative and negative, we can just cancel those out. we want to set it up like this and put the decimals there. But what we really want to do is we just want to basically times this 3. Just think of a 3. Forget about the zeros right now and just say that we have a 3. And let's pretend this is 248. We'll forget about the decimals at the moment. We'll put those in at the end. So it's 3 times this. So 3 times 8 is 24. So put a 4 here. Carry the 2. This times this is 12. Plus 2 is 14. Carry a 1. And this times this is 6. Plus 1 is 7. Now, we need to take into account the decimals. We have, after the decimal, we have 2 decimal places here and 3 here. So in the end, this decimal that was here, which is invisible, we didn't use it, right? We need to move it back. 1, 2, 3, 4, 5. So the final answer is 0.00744. And it's not a negative number because the negatives canceled out. So this is the final answer right there. All right, next one. It's 46D. All right, so we have 40.4 divided by 0.02. Well, I don't want to deal with this. Hold on, just one second. We can set up vertically, right, like this. I don't want to deal with this decimal, so I want to move it over. 1, 2. Well, what I do to the bottom, I need to do to the top. So 1, 2. So now I'm taking 4040 and I'm dividing it by 2. So 2 into 4040. There's 2, 4, 0, 0. How many times does 2 go into 0? Well, 0 times. So 0, 0 again. Bring down 0. I mean, because we're subtracting, it's a 0. Bring down this 4 now. How many times does 2 go into 4? Well, that's 2 times. And again, we have the same thing. So anyway, you know what we need to do. Put a 0 here. So it's 2020. That's the final answer. Well, this also brings up something that you should have memorized already. When you divide by something that's in between 0 and 1, right? What is this? 0.02 is greater than 0, but it's also less than 1. So when you're dealing with a fraction, basically, when you're dividing by a fraction, when you're dividing by a decimal, right? Something that has, that's like this, 0 point, something. It could be 0.000. Basically, when you're dividing by something that's in between 0 and 1, you get a bigger number, right? We had a 40, and in the end, we got 2020. So we got a really big number. So again, when you divide by a number that is in between 0 and 1, you get a really big number, or you get a bigger number. And when you times by a number, if you recall correctly, when we multiplied the 46C, we had a really, really small number in the end because we multiplied by a number in between 0 and 1. And it could be in between 0 and negative 1. So basically instead, because the 46 was a negative number, right? We had a negative 2.48, right? And we multiplied it by a negative 0.001. Basically, if the number is, so we'll call it x, if the number is greater than or equal to 0 and greater than 0 and less than 1, then we're going to get a really big number if we divide it, if we're dividing by this number. If we're dividing, this also holds true if it was greater than negative 1 or less than 0. Okay, if the number is greater than negative 1 and less than 0, again, we're going to, if we're dividing, if this is, dividing, if we're dividing one of these numbers, so we have like another number over here, like a whole number, like 2, if we divided by a number that was in between the 0 and the 1 or between negative 1 and 0, we're either going to have a we're going to have a bigger, depending on what the number is, we're going to have a bigger, it could be slightly bigger or it could be really bigger number that's either negative or positive. And if we times instead, we do a multiplication problem, it's going to be smaller. So remember, if you recall correctly, 46, we had 2.48, which is right there, and we times by this number. It's a negative number, right? So this number would fall into this category right here. When we times it, what did we get? Well, we got, in this case, we got a positive number because it's two negatives make a positive, and we got a really, really small number. It was 0.00744. Yet when we did D, which was 40.4 divided by 0.02, that's also between, it's in this category, it's between the 0 and the 1. We got a really big number. If you recall correctly, we got 2020. So it got bigger. So just remember, what I'm driving out here is when you divide by a number between 0 and 1 or negative 1 and 0, you're going to get a really big, you're going to get a bigger, sometimes a really bigger number that's either negative or positive. And if you times by a number that's in between 0 and 1 or negative 1 and 0, you're either going to get a slightly smaller or a lot smaller number that's either negative or positive. All right? Okay, let's move on to 47. And let's change colors again. So we want the 47, and we are evaluating an expression. And what's the expression? It's negative 2.103 divided by 0.03 minus 8.1 divided by 3. Okay, so let's do this. Let's do this one first. I'm gonna, oops, sorry about that. I'm gonna set this up as a vertical one so you can see what I'm doing real quick. I have this, and I'm dividing by 0.03. Well, I'm going to move this over 2 places, and then I'm going to move this over 2 places. So now really what I'm doing is I'm doing a 3 into that 2, it's a negative, but into 210.3. How many times does this go into this? It doesn't. How many times does it go into 21 though? 7 times. So we have a 7 here, and a 21 down here, and since we put that negative here, it's really a negative 7. That's why I don't deal with the negatives. Let's just get rid of those negatives. Oops. Let's get rid of that negative. There we are. That's why I don't want to deal with the negative. You can if you want, but I don't like dealing with them. All right, so we'll put the negative in later. So that's a 7. That's a 21. And then it's 0 and 0, and so 0 times 0 equals 0. Then we deal with the 3, right? So 0, 0. All right, bring down the 3. How many times does 3 go into this? 1 time. So 70.1. And we get a 0 here. All right, and then after that, all right, so this remember that's a negative, so let's put it over here. There's room over here. It's 70.1, and we're going to be minusing whatever this is. So let's deal with this. It's 3 into 8.1. How many times does 3 go into this? Well, 2 times. No, yeah, 2 times. And so 3 times 2 is 6. Bring this down, it's a 2. And then bring the 1 down, and how many times does this go into this? Well, 7 times. So 0. So we're going to be subtracting this from this. Now we're running out of room, so let's scroll this up. All right, so since this is a negative and this is a negative, we're really just going to be adding them and making it a negative at the end. So 70.1 plus 2.7 equals 8 right there, and this is 2 here, so it's really a negative 70, oops, I don't like that, really negative 72.8. That is the final answer, I would say. Well, let's double check. Yep, according to the answer sheet, it agrees with me. All right, 48. Here we go, 48. Evaluate the following expression. So we have j, k, plus L. What does that mean? That means that's J times K plus L. And they tell us what it equals. So j is 2.21, so we're going to replace it. So 2.21 multiplied by k, and k is a negative 0.01, and then we're going to be plussing L, and L is negative 3.01. All right, let's do this. Scroll up. All right. So when we times, all right, this means times. Let's do this. So it's 2.21 times that negative. We'll deal with the negative in a second. 0.01. So basically, it's just 1 times all that. So that turns into 2, 2, 1, and then we have 1, 2, 3, 4 decimal places. So we need to move back 1, 2, 3, and 4. So really what we have is we have a negative 0, negative 0.0, well, this is 0.0, there we go, that's more proper right there. So it's negative that plus a negative 3.01. So let's add those together. Because they're both negative, we can add them together and add the negative afterwards. So we have a negative 3.01. And we're going to be, we'll put the negative there for right now. We'll add the negative later. I don't want to deal with the negative. So it's 3.01 plus 0.0221. We can add some zeros here as well. There we go. So 1 plus 0 is 1. 2 plus 0 is 2. 1 plus 2 is 3. 0 plus 0 is 0. And then add the 3. So I would say, because it's negative, we're dealing with negatives, it's negative 3.0321. And the answer sheet, let's see if it agrees with me. We're on, what is it, 48? 48, yep, it agrees with me. It is negative 3.0321. Now that was 48A. Now let's do 48B. So let's erase that. And we're on 48B. We have x plus y squared. Well, x is is negative 2 and 7/8. Okay, and y is 1/4, but we're going to square it, so we're plussing 1/4 squared like that. So that's really negative 2 and 7/8 plus, when we square this, you can't see it now, but it's supposed to be squared. That's 1/16. Now, the problem with this is not a 6, this is an 1/8, right? And we also have a negative here, and this is a positive. So it's really kind of a problem here. Now, we can change this to an improper fraction if we want to, or we don't have to. Yeah, let's change it to an improper fraction, just for kicks. So 8 times 2 is 16, plus 7 is 23. That's negative 23/8. I don't know if I like this, but we'll do it anyway. Plus 1/16. All right. Well, common denominator is 16, so we need times top and bottom by 2. And we get, well, we have some room actually. Let's just leave it. We get a negative 46/16 plus 1/16. That's what we get. Now, what we need to do is we need to plus it, so we get a negative 45/16. And now we need to reduce this, or sorry, change it to a mixed number, because that's what they want us to do. So let's change it to a mixed number. So how many times is 16 going to 45? We'll remember the negative in a little bit. All right, well, 16 goes into 48 3 times, so it can't be 3 times, so let's say it's 2 times. This times 2, 16 times 2 would be 32. And then we do the subtraction problem, and that's a 3, and that's a 1. So I would say it's 2 and 13/16. But not just 2 and 13/16, it's a negative 2, because remember it's a negative. 2 and 13/16. And that's that. All right, next one. Let's do 49. 49a. 49a. That's x minus 3 1/5 equals negative 2 and 3/10. We need to add this to this, so it's really x equals negative 2 and 3/10 plus 3 1/5. Now we're gonna have a positive in the end here because this is bigger than that negative when it comes to absolute value. So we could rearrange this. All right, since it's an addition problem, we know that with addition you can use the cumulative property. I believe that's what it's called, where you can switch things up. And it's 3 1/5 now, and we're going to do plus negative 2 3/10. Oh, tenths, I think so. All right, now when we plus a negative, it's really a minus. All right, and I've talked about this in class. When you're dealing with the cumulative, I can't even say it now. The commutative, there it is, the commutative property, it only works with addition and with multiplication. It doesn't work with subtraction or division. But you can, if you put a plus sign in there, you can make a subtraction problem, because this is really what? This is really a subtraction problem now. It went from an addition problem, and now it's a subtraction problem, because a negative and a positive make a subtraction problem like this. So some of you, may be questioning how that works. Well, the reason it works, as I said in class, you can switch things up when it's an addition problem. So that's why it worked. It worked because we used addition, so the commutative property works with addition. But now that we've switched things up, it's now a subtraction problem, because a negative and a positive make a negative. So now it's 2 1/5, and we're minusing. 3 1/5, and we're subtracting 2 and 3/10 from it. Anyway, so 3 minus 2 is 1, and then we have a 1/5, and we're subtracting 3/10 from that. We can't do that without a common denominator, so we times both top and bottom by 2, and now that's 2/10, and we're subtracting 3/10 from this. And that's going to give us a negative 1/10. Well, now we're running into another problem. That's a positive, and this is a negative. Let's move this up. So we have 1, and it's really 1 minus 1/10. Well, that 1 can be rewritten as 10 over 10, and we're subtracting a 1/10 from it. Okay? All right, so 1/10, and subtracting it from 10/10, and so that is really 9/10. So the final answer is 9/10. Just real quick before we move on, I want to revisit this. According to the commutative property, if you had like 1 plus 2 plus 3, you could rearrange it to 3 plus 2 plus 1, or you could say it's 3, or you could say it's 3 plus 1 plus 2. You see, we can rearrange that. Now, you can't rearrange it with the subtraction problem. It's probably important that I'm going over this. So, for example, say we have 3 minus 1. Well, that equals 2. But you can't say that 1 minus 3 equals 2. No, it equals negative 2, so it doesn't work. So that's why the commutative property doesn't work. But if I switched it up, so let's go back, and let's say that I had, instead of 3 minus 1, well, let's just keep here. So instead of I had 3 minus 1, let's say I had 3 plus negative 1. You see that? I add that plus sign to it. That now is an addition problem. Now we know that a negative and a positive make a negative in the end, so we know that this really is going to be 2, that it's going to be 3 plus a negative 1. And that works because, you know, we have a 3 here, and there's a 0 and so on. We have 0 here and a 3 here, and when we're plussing a negative, that really means that we're going backwards 1, right? We're going backwards 1, so it's going to put us at 2 here. We know that works. Well, this also makes it so we can switch it up. So now if we switch it, we have a negative 1 plus a 3. You see how that works? So with addition, we can switch things up. So we can write a subtraction problem as an addition problem, and then if we want to rearrange the numbers, we can do that. Okay, so now it's a negative 1 plus a 3. Well, that does equal 2. See, these equal each other now. But again, if it was negative, if it was like this, and then we switched it to this, it's not going to give you the same answer. If you want to switch things up with the commutative property, you have to make it into an addition problem instead of a subtraction problem. And that's what I did, if you recall correctly, with the last one. We had here, we had x minus 3 1/5, right? 3 1/5 equals negative 2 and 3/10, and then it was x equals negative 2 and 3/10 plus 3 1/5. Hopefully you remember this. And then what I did, since it was an addition problem, I switched it. I did 3 1/5 minus 2 3/10. All right, just so you understand what I was doing. I thought I would refresh your memory on all that. All right, moving forward, 49b. Oops, b. All right, we have a negative 1 11/12 x equals negative 2. Well, what does this mean here? This is this times x. So I'm going to change it to, when we're dealing with multiplication and division, it's much easier to deal with that when it's in an improper form, improper fraction form. So 12 times 1 is 12, plus 11 is negative 23 over 12. That's what it is. X equals negative 2. Okay? All right. Now, I want to times by the reciprocal. So that cancels that out. We times this by the reciprocal too. So what I have is x equals, and this is a negative right here. So here's a negative 2, and this is a negative. So these cancel out, and this is a negative, and this negative cancels this negative out. So now I have 2 times 12, because again, when we do a whole number and we times it by a fraction, we times it by the numerator, the top number. So it's 12 times 2 is 24. 24 over 23. Oops. 23. Now, if it doesn't specify that you need to have it in improper fraction form, I mean, as mixed number form, to say, then you can leave it as an improper fraction. But thus far, it's always been, even though it doesn't specify it, it's always been thus far as an mixed number, so we change it to a mixed number. Sometimes it's 23 going to 24, well, one time. And then 23 minus 24 is 1, so it's 1 and 1 over 23. So it's 1 and 1/23. That's the final answer. Again, on the test, if it doesn't specify that you need to change it to a mixed number, then just leave it as an improper fraction if that's what you feel most comfortable with. But if it does specify it, make sure that you make it a mixed number. All right, next one. We have negative 12.48. And we're going to be multiplying, we're going to be adding x, and that's going to equal negative 32.14. We're going to add this 12 to this, so it's really x equals negative 32.14 plus 12.48. Now, when it comes to absolute value, the 32 is bigger than the 12. So we're going to have a negative in the end. So we can think of this instead of as a subtraction problem. All right, so you do this, and then we could make it a plus, and then put on the outside subtraction like this. So make sure that's negative at the end. Oh, not plus in the middle, sorry. No plus here. We want that as a negative. So we're minus. Sorry about that. Alright, so now we still from here, and we make this a 14. This is a 6. Then we still from here, make that a 1, make this a 10, make this a 6. Then we still from here, make this a 2, make this an 11, and this is a 9. And then 2 minus 1 is that. And it's a negative in the end. So negative 19.66. That's what I would say the answer is. Alright, next one. Next one is 4.05x equals negative 0.81. Alright, what we're going to do is we're going to divide this into this. Okay? So it is 4.05 times x. To get x by itself, we need to divide. So it's really going to look like this. Alright, we're dividing. Alright, so but here's the problem. I don't want to divide by something with a decimal, so I'm going to move this over 1, 2. And I'm going to move this over 1, 2. And so really, x equals 405 into the 81. Alright? It's negative 81, but I'll put the negative in a little bit. So how many times does this go into this? Well, it doesn't, so we add a 0 here. Put a point here, add a 0 down there. How many times does this go into this? 2 times. And where are you going? I know it's 2 because I can see it, but just in case you can't see it, this times this is 10. Add a 1 there. 2 times 0 is 0, plus 1 is 1. And then 2 times 4 is 8. Alright, so we're done. So that's the answer. Oh, nope, not quite the answer. I almost forgot. It's negative 0.2 is the answer. Alright, next one. 50. 50 is translate the following into an equation to solve. So a number multiplied or times 1 over 13 is 1/2. So really what we have is we have this, all right, 1/13 times x equals 1/2. We're times by the reciprocal, which is this 13 over 1, which is 13. And then so now it's really x equals 1/2 times 13 over 1, which turns into 13 halves. And then, you know, I've showed you how to change it to a mixed number before, and so I don't really care. I'm just going to leave it here. I guess if you wanted to, you could change it to a mixed number, and you'd say 2 goes into 13 6 times, which is 12, and then you'd minus the 12 from the 13, and you'd have 1, so it's 6.5. Alright. Alright. Next one. Oh, is it now? Yeah, 6.5. Next one. Next one is, it says the sum of 15.01 and a number. So I would say it's negative 15.01 plus x equals 1. Well, that's easy. We're just going to be plussing this to this, so it's really x equals 1 plus 15.01, or that equals 16.01. There's the answer. 16.01. All right. Next one. Let's see here. 51. 51 is your paycheck from May was $1,483.12 before taxes. Deductions of 201.89 and 32.1 were made for federal and state tax respectively. What do you take home, basically? So you just basically, it turns into a subtraction problem. But before we subtract, I'm going to add these two things. All right. So this turns into a 10, you carry the 1, 9, 3, 3, 2. So I have 233.90, and I'm going to be subtracting it from the original number, which is 1,483.12. All right. So 233.90 is what I'm subtracting. This is a 2. I get a still from here. That turns into a 2 here. This turns into 11 here. This turns into a 2 here. Still from here. This is a 7 now. This is a 12. This is a 9. 7 minus 3 is a 4. And then 12. So basically what you're going to take home is $1,249.22. Yes, it's very satisfactory. It's very gratifying to know that the government is stealing $233.90 from your check. Most satisfying. Makes you want to go to work, doesn't it? All right. Let's see here. 52. A cereal box contains 9 3/4 cups of cereal. One serving is 3/4 cup. How many servings are in a box? Well, that means that you can subtract 3/4 of a cup over and over and over again, or if you recall correctly, one way of looking at division is multiple subtractions, basically, right? You're subtracting the number over and over again. So we could divide this by 3/4. That's one way of looking at it, and that's what we're going to do. So, how many 3/4 cups go into this? That's what you need to ask yourself. Well, we're going to change this to a mixed number. All right? Not a mixed number, sorry. It's a mixed number. We're going to change it to an improper fraction. So this times this is 36, plus 3 is 39. So 39/4. And when we divide by a fraction, we times by the reciprocal, so it's really times by 4/3. Well, that's easy enough. This cancels this out. This cancels this out. 13 is really, not 13. 39 is really 3 times 13. So we can cancel that 3 out, this 3 out. Look at that. We've canceled this out, we've canceled this out, we've canceled this out, we've canceled that out. Cancel that out. All we have left is 13. Voila. There are 13 servings in that cereal box. 53. We are coming to a close here. We only got a little bit more. Determine the value of each expression. So it says 21% of 12. Well, that just means times. Remember, of means times. So it's 21% is 21 over 100, and we times that by 12, which is 12 over 1. Well, before I start doing some things here, I want to reduce, if I can. What's 12? Well, that is 4 times 3, is it not? And what is 100? Well, we could say that's 4 times 25. Could we not? Yes, we could. So we can cancel this out and this out. Isn't that nice? All right, and then it turns into 21 times 3. Well, 21 times 3 is going to be 63. And then we divide that by 25. That's what we would do, but now we're not done yet because we now need to, guessing what they want us to do here is they want us to change it to a mixed number, or, well, we don't want to change it because it says percent. What's the percent? 20% of that. So let's just actually change it to, I think, to a decimal, but we still got to divide. So 25 into 63. How many times does it go into it? Well, twice. 50, you see? And then a 13. Yes, I think you see that. And then we put a point here and bring down the 0. How many times does this go into this? Well, at least 4 times. Let's say 5 times. All right, we know that 4 times 25 is 100, right? See over here? 4 times 25 is 100. So 4 times 5 would be 125. All right, with the remainder of 5, bring down the 0. So 25 times 2 equals 50, and we're done. So the answer is 2.52. So 2.52 is 21% of the 12, and now we're done. So that's the final answer, 2.52. All right, let's do the next one. That was, by the way, 53A, just in case you're wondering. Now let's do 53B. 53B. Whew, all right, we have this divided by 10%. Well, we need to remember that 10% really is 10 over 100. And we can reduce that to 1 over 10. So it's really this. And when we divide by a fraction, it's really timesing by the reciprocal of that, right? So we times by 10 over 1. Well, it's just then basically this times 10. So we just add a 0. Done. So it's 8,500. All right, next one. 54. 54a. Oh, goody. We're almost done. It is 2 over 15 equals 6 over x. Cross multiplication gives us this times this, which is 2x. This times 15. 90, I do believe, but just double check. That's a 30. Carry the 3. Yep, 90. And what is half of 90? Well, you should know that it is 45. You need to memorize that. Half of 90 is 45. All right, you can do long division to figure out yourself, but we have it memorized because we've done this before. We've done something similar to this, so we know that it's 45. All right, 54b. 54b is 2.1 over 30.4 equals this over this. All right. So what we're going to do is we're going to do cross multiplication again. This times this is 21. Why? Well, when you times anything by 10, you move the decimal place over one place. We've done this. We've talked about this before. Anything times 10, we take the decimal and we move it over 1. Just like anything times 100, say we had 2.1 times 100, we just move the decimal over 2 points. So it would be this. All right. So 10 times 2.1 is 21, okay? All right. And then this times this equals 3.4x. Now, we need to divide by 3.4. So it's 21 divided by 3.4. We're going to move the decimal over because I don't want to deal with the decimal. And if we move the decimal there, we got to move the decimal here. So it's really this. So it's really 34 into 210. How many times does 34 go into 210? Well, I know that if I round down to 30, that 30 would go into 210 7 times. But this is bigger than 30, so only 6 times, I'm guessing. So 34 times 6 is 24. Carry the 2. This times this is 18. 18 plus 2 is 20. There we go. So we have this. And then we subtract, and we're going to have a remainder of 6. Add a 0. Add a point here. Let's move this up. We're running out of space. And then how many times does this go into this? Well, just once. 34 into this. Still from here, make that a 5. Make this a 1. I mean a 10. Make this a 6. And make this a 2. 260. All right. And does it tell us to round? Because I don't want to continue forward if we have to. No, there's no rounding, but I will round, I think, in the end if I have to continue doing this. Oh, it does, right there. It says, for part B, round your answer to the nearest tenth. Well, I'm at the 10th right here. I need to go to the 100th if I want to round to the 10th. So how many times does 34 go into this? Well, I know that 34 went into 210 6 times. So, I mean, common sense tells me that it's above 5, right? You can round the 10, this 10th place. You can round it up, or you can leave it to where it's at. As well, but we're going to round it up. Why? Because if the number to the right of it is 5 or bigger, we round up. We know it's going to be bigger because we know that 210, we're using common sense here, we know that 210 times 6 equals this, right? So we have 260, so we know that it's going to be even bigger than 6. But, we'll just say it's 8. And we'll put an 8 there in a second. I know we don't really need to do this, but for those of you that didn't follow my logic, I'll just show you. So 8, 34 times 8. We'll say it's 8. Well, hopefully that's going to be it. So that's going to be 32. Carry the 3. This times this is, 24 plus 3 is 27. That's too big, so we can't use 8. So let's try 7. This times this is 28, carry the 2, this times this is 21, plus 2 is 23. Yeah. So I'm going to have to say that it's 7. And then when we add the 7 up here and this down here, we're finished. We don't even need to subtract. We will, just because we want to be thorough, since we've gone this far. And then this is going to be a 2 here, right there, and that's a 0, so it's 22. So anyway, that's going to be the final answer. Well, not quite. We need to round this, because that's a 7. It's greater than or equal to 5, so it's really 6.2 is the answer. All right, moving forward. We are now on 55, and the rest are going to be word problems. So 55, you work at a catering company and you must decorate cupcakes for the event. Your boss has left out the exact number of boxes that need to be filled with cupcakes. After decorating, so you've decorated so far 160, you see that exactly 4/5 of the boxes are filled. That means that you've only filled 4/5 of the boxes. That means that you haven't filled all the boxes up. So we could set this up as a proportion. You have 160 so far, but 160 means that that's only part of them, right? And that's equal to 4/5. So we'd have to have x underneath, right? Because really, if you haven't understood this so far, so you understand, hopefully you will understand this. Basically, when you use proportions, you're saying that this fraction is equivalent to this fraction. Well, 4/5 is part of 4 is part of 5. If you had 5/5, then you'd have 1, right? It wouldn't be a fraction anymore. You'd have 100% of them. We haven't done 100%. We've only done 160. We've only filled 4/5 of the boxes. And so what we have is we have a proportion here. We need to find out how many boxes in total there are. And this 4/5 is really just, a reduced form of this fraction over here. All right, anyway, you'll see what I'm talking about. I'll show you in a second. So what we can do is we can times by x, and then divide by the reciprocal, or we can do cross multiplication. I'm going to do cross multiplication. So this times this, and this times this. So it's 4x equals 160 times 5, like so. And then we divide by 4. 4 and 800 is going to be 200. Well, what was I talking about before? I said that this is an equivalent fraction of this, means that this is a reduced fraction of this. Well, let's just see if I'm right. 160 over 200. If I divide both top and bottom by 10 first, I'm going to get 16 over 20, correct? Yes. And if I divide both top and bottom by 4, 16 divided by 4 is 4. 20 divided by 4 is 5. Aha, look at that. Yes, you can see that I was correct. And now we're moving on. So 56. Oops, that looks ugly. We haven't changed. We need to go to a different color. We haven't done a different color for a while. So 56. All right. 56 is last year your state recorded 5,982 live births. This year, the number jumped to 7,000. Good Lord. So basically what they wanted you to know is, what is the growth factor of live births over 1 year, period? What is the growth factor? Basically, how far did it go up? How much, what growth factor means if you took the 5,982 and you times it by a certain number, it's going to equal this, okay? All right. So you could divide by this and you'd get the factor. So you divide by that. Another way of setting that up is you can say that you had the original number of this, okay? So let's see here, hold on. This was the original number, okay, 5,982, because we're basically, this is what we've talked about. This is towards the end of this class, this semester, we talked about proportions. So this is the original number, like so. This is another way of setting it up, if you will. And the original number always is next to or across from 100. And this bigger number basically is bigger than the original number, so it's going to be a bigger. This is percent, remember? Hopefully you remember this. You could have done this right here and been done with it. You could have done 7,000 divided by 5,000 and you would have found the growth factor. But if you want to continue using proportions, you can remember what we taught you before. Basically, you had 5,982, and that was 100%, right? And then we added a certain amount. What did we add? Well, we added x to it, and we had now 7,000, like so. Okay, and basically we want to know what percent this is. Okay, what did we add? What percent did we add here? Okay, so we don't know what that is. It's X amount. We don't know what percent we have in the end. All right, so it's this over this and X over 100, like so. Anyway, that's what we've done before, proportion-wise. And then we do cross multiplication if we want to. And when we do cross multiplication, this is all full circle. Hopefully, if you didn't understand before kind of what we were doing, let's erase this. Let's make this a little bit bigger. It makes it easier for me to erase. Oh, that's way too big. Oh, goodness. Okay. That's a little bit bigger than that. All right, good. Move this out of the way. We'll make it smaller again. If you recall correctly, that's kind of how we set up the proportions before. You know, I don't really need to erase that, but who cares? So, if you recall correctly, that's how we set up the proportions before, and then we do cross multiplication. Well, what happens when we do cross multiplication? Well, we get this times this, and this times this, and then we'd find the percent, basically. We'd find what this percent equaled, okay? So let's go ahead and do that. Basically, we want to know what the factor is. So let's go ahead and do that. All right, so 100 times this, so it's really, and cross multiplication, like so. All right. All right, then when we divide, I'm going to use my calculator because I want to keep it all. The reason I'm doing this, one, to save some time, and also kind of help you see this. When I use my calculator, oh, by the way, this is add 2 zeros because we times by 100. I have that 700,600, and I divide it by the 5,982. All right, and that is going to give me, I'm going to round, that's going to equal when I divide, so x equals, let's see here, I'm dividing so you can see this. I'm going to be going up and down, trying to help you out here. I'm dividing, this is x equals all of this divided by this, okay? And that equals, more or less, 117 point, no, I'm just going to, it's 1 something something. I'm just going to round, so I'm just going to say it's 117, okay? That's what that equals. All right, and then if you recall correctly what we had below, all right, hopefully you remember this, and if you don't, you can reverse it. I had what? I had this, correct? 5982 over x over 100. And that was, if you recall correctly, I had 5982 plus a certain amount, we don't know what it is, equals that, equals this, right? And then over here we had 100 plus a certain amount equals x, right? We're plusing a certain amount equals x. And then when we had it set up, in the end, we would have this x here, we cross multiplication, and we'd replace this x with 117. Well, what that means is it's gone up 117%. That's the growth factor. It went up 117%. Okay? Well, that's how much it went up by, basically, 117%. Okay? All right. So what I'm getting at, that's the same thing as this. Okay? If we're dealing with a percent, the growth factor is a little different. The growth factor is not percent. It's just a multiplication. You times this by this. Well, if I do that and I do it in my calculator, I'm going to get 1.17, which is the same thing almost as this down here. See? Let's move over here. 1.17 is the same thing as 117%. Why? Because I've told you, if you want to change something to percent, you got to times by 100 and then what? Add the percent. So they are equivalent. Anyway, a growth factor is the same thing as the next question. I taught you all this because the next thing it says is, what is the percent increase? Well, the percent increase is 117%. I just did both problems, basically. I just did part A and part B. Part A would be just this, by itself. Okay? It all got very confusing, I think, for some of you. And this would be part B. I was finding the percent in part B. But basically, the percent and the growth factor are the exact same thing. One's just represented as percent, and one's represented as decimal. All right, maybe I'll do it one more time for you, for those that are confused, okay? All right, 56A, okay? Basically, this is what you start with, and you're multiplying it. Growth factor means multiplication. So something times the 5,928, oh, not 28, 82, equaled this 7,006. All right, well, that's just x equals 7,006 divided by 5,982. All right, well, I was trying to teach you before something full circle. I was trying to get you to understand the big picture, okay? But if I confused you, all you need to do is divide this. And you use long division. I'm not going to do it because I don't want to, and I'm just going to round and use my calculator, and it's 1.17. All right, if you use your calculator, you'll see that it is 1.17. All right, that's the answer. That's the growth factor. 1.17 times this equals that. Okay? All right. And basically, they want you to see full circle as well. They want you to see what it is. I want you to understand a hopefully full circle as well. Because now they're asking in B, what is the percent increase? So basically, you had 5,982. All right. And now it is 7,006. And if you're talking about the percent increase, well, basically that's how you set it up, right? You have 100%, and on top would be a bigger percent. And why? We'll go over that over one more time. One more time. You might be bored with it by now, but one more time. You plussed it by a certain amount. We don't know what that was. It equals, in the end, this, if you recall correctly. We've done this before. Well, 5,982 is 100%. All right, that's the original number. All right, it was plus by a certain amount of percentage, a certain percentage, and then we get this percentage. Okay, so that allows us, all right, this over this, and this over this. All right, so that is over that, and that is over that. So this is going to be bigger. And then when we did cross multiplication, you saw earlier in this video, just a couple minutes ago, that equaled 117%. That's what the x would be. And this is percent form, this would be percent form. Hopefully you understood that. It was a little confusing, but I was trying to help you see full circle. This problem helps you see, the big picture as well. And hopefully you understood that. All right, here we go. Next one. 57. 57. Almost done here. All right, 2014 Volkswagen Jetta Hybrid has a highway mileage of 48 miles per gallon and a fuel tank that holds 11.9 gallons. How many highway miles can this car travel on one tank of gas? All right, there's two things you could do here. You need to know that basically rate times time equals amount. All right, we've gone over this. All right, you could set it up like this. You could say that since it's 40 miles per gallon, hold on a second. Rate times time equals amount. Oh, sorry, I'm using the wrong one here. So rate times, in this case, would be gallons. Rate times gallons equals the miles that you go, right? The miles, okay, that you're going to go. So you could set it up like that. This is 48, and then times the 11.9, and that will give you the amount of miles that you can go on a tank of gas. Okay, you can set it up like that. You could also set up as a proportion. Let's set up as a proportion. Since you've learned proportion, let's just set up as a proportion. All right, basically with a 48 miles per gallon, what that means is miles per gallon, 1 gallon. That's the proportion. All right. So it's 40 every gallon you get 45 miles. That's what this is saying. All right. Well, they want to know how many miles you can go with 11.99 gallons. Okay. Well, then you just do cross multiplication. This times this. So we've done this. That's why I said you could do 48 below. Remember, I said you could do 48. I mean, it would be 4. Oops, well, that wasn't good. I said you could do 48. Oh, I deleted it already. Like I said, you could do 48 times 11.9, and that would give you the amount of miles. If you recall correctly, if you rewind the video. Well, you can see that's true. When we do cross multiplication with the proportions here, 11.9 times this, and 1 gallon times this will give us what we need, okay? Here we go. So 48 times 11.9. Let's reverse that a little bit, actually. 11.9 times 48. We'll put the decimal in later. Now, I don't need to worry about the 1 gallon times x because that's just going to equal x. All right, so this times this is 72. Carry the 7. This times this is 1 plus, this times this is 8 plus 7 is 15. Carry the 1. And then this times this is 8 plus 1 is 9. Add a 0. This times this is 36. Okay, carry the 3. Let's put 3 up top. Scribble that out. This times this is 1 plus 3 is 7. And then this times this is 1, so it's, not 1, it's 4. All right, so we get 2 here, and we get 11 here, carry the 1, 7 here, carry the 1, 5. Now you might want to say we're done, but no. Remember, we have a decimal place here, so we need to go back 1. So you're going to go 571.2 miles on a full tank of gas. All right, 58. We're almost done. Just one more after this. At your favorite grocery store, lean ground beef costs $4.99 per pound. All right, it's $4.99 per pound. All right, you could have said also per pound. That's a proportion. This is just written horizontally. It's $4.99 per pound, per 1 pound. Okay? All right. And how much would you pay for? All right, this is dollars. All right, how much would you pay for 4.9 pounds? Oh, 4.6 pounds. That's how you set up as a proportion. Cross multiplication. So 1 pound times x is just x. So x equals 4.6 times that 4.99. So 4.99 times 4.6. This times this is, it's 54. So 4 here, carry 5. 54 again, plus 5 is 59. Carry 5 again. This times this is 24. Plus 5 is 29. All right. And then we need to, just going to take that down a little bit. We need to now add a 0, and we have a 4. 4 times 9 is 36. Put a 6 here, carry 3. Okay, this times this is, again, 36 plus 3, not 5. Plus the 3 is 39. Put the 9 there, carry the 3 again. This times this is 16, plus 3 is 19. So we have a 4 here, we have a 5 here, carry the 1, we have a 19, carry the 1, we have a 2, carry the 1, another 2. That's this plus this is 12. And carry the, oh no, it's, yeah, 12, you're right. So 12, carry the 1 is 2. And then we got to remember that there's 3 decimal places, so we need to go 1, 2, and 3. So in the end, you're going to pay $22.954. I imagine they want us to round, do they? Yep, round to their cent, so it's right here. And therefore, this 4 is less than or equal to 5, so it's just 22.95. All right, $2.95. $22.95 is what you're going to pay. All right, last one, 59. Let's do it. 59. Last year, Small Community College had an enrollment of 9,855 students. This year, the college enrollment decreased by 4%. All right. So, what is this new enrollment? All right. So we have 9,855. All right. Hopefully you'll get here is hopefully you'll be able to set up like this. Hopefully you'll be able to set it up right away without having to do what I'm going to show you in a second. You'll be able to set up like this. You have now X amount of new people. a new enrollment. This is what you had before. This is the original number, right? And you'll also be able to realize that 100 goes with the original number, and that since it went down by 4%, you are really only going to have 96% that attend. Hopefully you'll set it up like that. But if you didn't set it up like that, if you didn't know that you need to set it up like that, then you'll remember hopefully this instead. Let's get rid of that. You have 9,855. You're going to be subtracting a certain amount. You don't know what. You're going to have X amount in the end. 100% over here. You're going to be subtracting 4%. So you're going to have 96 here. So it's 96 over 100, X over that, and that's where we get, that's where we get this. You see? Hopefully you got that. So now, let's erase all that. No, let's make it bigger. Make it bigger. There we go. Did I get it all? Oh, not quite. There we go. All right. Let's finish this problem. Cross multiplication. That's what we need to do. Oh, actually, I'm not going to do cross multiplication. Take it back. Yeah, let's do cross multiplication. Yeah, let's do cross multiplication. So it turns into 100x, and then we're going to take this and multiply by that. So 9,855 multiplied by 96. 6 times 5 is 30, carry the 3. 30 again, plus 3 is 33, 3, carry the 3. This times this is 48. 48 plus 3 is 51, carry the 5. This times this is 54. All right, 6 times 9 is 54, plus 5 is 59. Add a 0, this times this is 45. Carry the 4. Carry the 4 right there. This times this is 45 again, but now it's 49 because it's plus 4. So we put 9 there, and then we carry the 5. Oh no, we carry the 4 again. So it's 49. All right, 45. Let's double check. Yep, and then 40. Oh, wait a minute now. Yeah, 45 plus 4 is 49. Carry the 4 again. This times this is 72 plus 4 is 76. Carry the 7. This times this is 81. 81 plus 7 is 88. Goodness gracious. 0, 8, 10. Carry the 1. This plus this is 16. Carry the 1. Then we have 14. Carry the 1. Then 9. So that equals 9, 4, 6, 0, 8, 0. And then when we divide by 100, we just move it back 2, 1. Oh, we're going to divide by 100 in the end. See, to solve for x. And that just means we're going to move it back 2, 1, 2. So I would say that x equals. Let's see if the answer sheet agrees with me. It appears that. Wait a second, hold on. Wait a second. Does it say to round? Aha, there it is. Yep. So technically, before we round, x equals 9460.8. But it does tell us to round to the nearest whole number, which is right there. And so it really turns into 9461, which is the answer according to the answer sheet. And there it is. So now the amount of students that enrolled is 9,461. And if you wanted to check, you could plug that in. You could plug it into right here into this x, and it would, with your calculator, since we rounded, with your calculator it would equal more or less 96. If you 96%, you'd get 0.96 something something with your calculator if you divided this number down here by the original number, which was 9,855. All right. I wish you luck on the test. I'll see you later on next week and during the final, and you have a good weekend. All right, bye-bye.